Woohoo! We're live. This is Math 40 Elementary Algebra. We're doing some word problems. This is not puppies and cotton candy. Sadly, it's word problems. And we're using word problems to study systems of equations a little bit more deeply. So this and other problems, we're getting a couple of warm-up problems to get you ready to start the homework. This one's a little bit different. This is one that we haven't talked about in a long time. This is a distance, rate, time problem. And this one is a little bit challenging, but hopefully by the time we're done, it'll make sense. And the nice thing about it also can be described using a system of linear equations. So let's get into it. First thing we need to remember is our dirt equation. Distance equals rate times time. And that's an equation you want to stick into long-term memory. This is going to be useful for as long as you're in math, and especially if you end up taking more science, especially physics, possibly chemistry. I'm not sure. Chemistry gets a little bit confusing for me there in the middle. So it could be anything really there in chemistry. So distance equals rate times time, and I call it dirt because I think of the E for the equals. So D-E-R-T, dirt. And we're going to look at this and we're going to talk about boats. So I need a boat and some water. If I have water and it's moving in a direction, let's say the water is moving this way. If you move with the water, it's considered downstream because in general, water is going to flow down. Now, if you actually look at a creek, sometimes they technically are going up a little bit, but that's because, the water gets going and it's kind of like a super fun, water slide for the water. That's an interesting question. Does the water enjoy the water slide? I don't know. So if you go with the water, you're going downstream. If you go against the water, you're going upstream. So we got to know which direction is downstream. And you'll notice that the problem says a boat traveled 30 miles downstream in 3 hours and made the return trip back upstream in 5. So you see this, you see it happening here. It's going to go faster to go downstream because you're traveling with the water. And it takes longer to come back up because you're traveling against the water that's pushing against your boat. So find the speed of the boat in still water and the speed of the current. So let's talk a little bit more about physics. Woohoo! So if we've got the water and it's heading this way, and you've got a boat, there's our boat, and let's let B equal the speed of the boat in still water. And let's let C be the speed of the current. Current is the word for how fast is the water moving downstream. So here's the thing. If you are in your boat and your boat is going this way and the water is going this way, so you're going with the water, your speed equals the speed of the boat plus the current. Now, if you decide to go the other direction, and I know I drew a sailboat, so that's confusing things, but let's just assume it's a flag. You're a pirate. Arr. If you're fighting the current, the water's going one direction, you're going the other, then your speed is the boat minus the current. Literally, the current takes speed away from you. So it's kind of cool. It's kind of simple. If you're going the same direction, you add them. If you're going different directions, you take the difference. So having said that, we've got 2 trips, and I'm going to approach this the way we approached distance, rate, time problems in the past. So I'm going to set up a chart. Woohoo. I'm only going to have 3 rows. And as usual, the top corner is going to be a smiley face or whatever you want to put there. And then before, you might remember what we did was we did the rate and then the time, rate times time. equals the distance. So I'm going to turn the distance equals rate times time formula backwards. And then I'm going to go, this is going to be downstream. This is going to be upstream. So I've got downstream and upstream. And downstream means with the water. So this is downstream. Can you see that? Yep. So my speed is going to be B plus C. This right here, this is upstream. When I'm going against the water. And so my speed is B minus C, the speed of the boat minus the speed of the current. So now let's look back at the top. It tells me that downstream, it's going to be 3 hours, and upstream, the return trip in 5 hours. So downstream is going to be 3 hours, and upstream is going to be 5 hours. So far, so good. And we were told the distance, but it was sneaky. It was at the very beginning, said a boat traveled 30 miles downstream. So, and then there was a return trip. So we assumed that the distance there is equal to the distance back. Now, normally what we would do is we would multiply across and we would add down. But we're not going to do that in this case. This one is strictly a multiply across problem. Why is that? Well, we don't have a total. We don't talk about the total trip or the whole thing. We just have these two pieces. So what I'm going to do is from each piece, I'm going to come up with an equation because I do have that multiplication across. So from this top one, I've got B plus C because my rate times my time is going to be equal to my distance times 3 equals 30. And my second one, B minus C times 5 equals 30. Now, I know a lot of you are looking at this going, how in the heck would I have been able to do this without you? And the answer is you wouldn't. This is why they pay me the big bucks. I am paid to try to explain how to approach these, and then you watch me approach these, and then hopefully the rest of the homework starts to make a little sense. But again, these are going to be challenging. This is word problems. So be gentle, give yourself half an hour at most. If you hate a problem after 10 minutes, give yourself a break then. So give yourself a break when you really start to hate the problem if you can't get to the answer, and ask me for some help. And remember that when you ask me for help, you want to be clear. Do you want me to show you the whole problem, or do you want me just to tell you what the first step is or the next step? Do you want me to look at your work and to tell you what was correct, where you should keep going, or if there are any mistakes? So let me know what kind of help you'd like. Okay, so I'm going to take this. I've got this equation, B plus C times 3 equals 30. And what I'm going to do is I'm going to divide both sides by 3. So I get B plus C equals 10. So far, so good. Then I'm going to take this equation, B minus C, and do exactly the same thing. I'm going to divide both sides by 5. And I get B minus C equals 6. Okay, so then B plus C equals 10. B minus C equals 6. You know what I'm going to do with this. And again, you can use substitution. I'm going to use elimination. I'm going to add these two equations that I got right here. One for the downstream, one for the upstream. And I got 2B equals 16. So B equals 8. Okay. B plus C equals 10. So 8 plus C equals 10. So C equals, you got it, 2. So the speed of the boat is 8 miles per hour. How the heck did I get miles and hours? Miles and hours. And C equals 2 miles per hour. And we did it. You did it. You're brilliant. Remember, be patient, be kind to yourself, yell at the math, not at yourself. And I will see you guys next in chapter 5. Woohoo! Congratulations, you made it to the end of chapter 4. Woohoo!